We're going to take a look at the Earth's rotation and also time zones. And right here, first we're going to take a look at the Earth's rotation. When viewed from the North Pole, the Earth rotates counterclockwise, and that's going to be on its axis. It's spinning counterclockwise. We can actually figure out the rate that the Earth is rotating based on a couple of things. First of all, the rate of change formula, which is right in your reference table on the front cover. We're going to look at a change in value over time. Okay, the change in value is going to be how many degrees the Earth is rotating, which would be 360. It takes 24 hours for the Earth to rotate once. So we divide 24 hours into 360 degrees, and we get the rate that the Earth rotates, which is 15 degrees per hour. This is a number that you need to know. This is not in your reference table, but that's the rate that the Earth rotates, and it affects a lot of things dealing with time and time zones on Earth. Now, the reason we're talking about time zones right now is because time zones are related to longitude. Okay? Solar noon is the time when the sun is at its highest altitude in the sky. Okay, so when you look out at noon, that is the highest that the sun will be all day. This causes noon to occur at different times around the world, okay, because the Earth is round. And that gives us a need for many different time zones. It wouldn't make sense for it to be 8 o'clock in the morning here when it's completely dark on the other side of the world. So they have different time zones to accommodate that. Okay, just to give you a better idea of what it looks like in the sky, this is the Earth if we're looking, and you can see this is kind of like the dome of the Earth or the sky above us. The sun rises in the east. Solar noon right there is at its highest point. Notice that it's not directly above us. In New York State, the sun is never directly overhead, and that's something we'll be talking about later on this year, but the sun never reaches what we call the zenith, or the point directly overhead. But you can see right there, there's solar noon. And solar noon also, if we're looking down at the Earth from space, here's the North Pole, solar noon would be right here when the sun is directly on that part of the Earth. Well, you can see that's 12 p.m. On the other side, it's 12 a.m. You don't want it to be 12 p.m. if it's completely dark out. Now we can see that the Earth is rotating counterclockwise, and there are 12 hours in between each side. So it's 12 p.m. to 12 a.m., 6 a.m. to 6 p.m. Okay, and you can see how the Earth is rotating. That's something you need to be able to do, is to interpret what time it might be at different points around the world based on a diagram similar to this. So definitely copy this down. You should be copying down any diagram that you see on any of these boards throughout the year. Okay. Each time zone is 15 degrees wide and covers 1 hour of time. The reason why it's 15 degrees wide is because of the Earth's rate of rotation being 15 degrees per hour. If the Earth is rotating 15 degrees in 1 hour, one time zone is going to be 15 degrees wide. Okay? And there are some time zones that are adjusted to fit local areas. If you've got an area or a major city where there's a time zone that cuts straight down through it, they move the time zone line to go around it. If you think about, like, there was a time zone that cut Carthage and West Carthage in half, it would be really confusing trying to get around town every day if it was an hour different on either side of the bridge. So that, is something that they definitely do for other areas, is they'll move that time zone line around to accommodate those major cities so that it's not too confusing for those people. Now, if we take a look at this diagram right here, if we're looking at a map of the world and we have these lines of longitude, okay, right here is the prime meridian, 0 degrees, all right, and you can see how the times are changing by 1 hour either direction, okay, and also you can see that it is in increments of 15 degrees, because again, we said each time zone is going to be 15 degrees wide. So if you are going to the west, okay, you're going to subtract time. If it's 12 p.m. in Greenwich, England, then 15 degrees to the west of that, it's going to be an hour earlier, which would be 11. and then you just keep going and keep subtracting hours as you move further and further west. As you go towards the east, it's the opposite. Okay, 15 degrees east, it's an hour later. You go 30 degrees east, it's another hour later. So these, if you figure out, okay, that's 45 degrees, okay, 45 degrees from 0, that's, you divide that by 15, you're going to get 3 hours difference. Okay, and since you know it's to the east, you're going to go ahead and you would add that out, those 3 hours. All right, so down here you can see, add 1 hour every 15 degrees east you move, and subtract 1 hour every 15 degrees west you move. So it wouldn't even matter if you were at 30 degrees west. If you're going to move 15 degrees towards the east, this direction, you're going to add that hour. Okay, so we'll be practicing this in class, but you definitely need to copy this diagram down so that you can understand how that works. Okay, and again, the time at the prime meridian, or 0 degrees, is called Greenwich Mean Time, and I think I said before it's called that because the time, or the prime meridian, actually cuts straight down through a village in England called Greenwich, England. So that's kind of the basis for the time. Okay.